Let's continue this investigation. State the domain of each of these things. State the domain of f of x. Okay, let's see. The domain of f of x is x such that x cannot equal to positive 2. X cannot equal to positive 2. Because if so, that would make the denominator 0. Let's see. Describe the behavior as f of x gets closer to 2. Well, I'm sorry, that's a positive 2, by the way. As this thing gets closer to 2, what's going to happen is this guy's going to deflect down and this guy's going to deflect up. There we go. Like that. Alright, let's take a look at this one right here. G of x is equal to x plus 3. Well, the domain of that is x cannot equal to negative 3, which tells me there's a vertical asymptote at negative 3. 1, 2, 3. And it's going to do the same thing. It's going to deflect down here and it's going to come up here. Now, h of x is 1 over x squared, so the domain of that is x cannot equal to 0. X cannot equal to 0. The graph will look like this. As it comes on this side, it's going to deflect up to infinity. As it comes on this side, it's also going to deflect up to infinity, because a negative number squared is going to be a positive number, so it's always going to stay on the positive side. That's kind of what's going on there. Make a generalization about this thing right here. Well, this thing has a domain problem anytime that x is equal to a. So x cannot equal to a. So what I'm going to say about this, I'm not going to write this down because my pen writing is very sloppy on this computer, but basically all of your vertical asymptotes would occur at whenever x is equal to a. In the space provided, draw the coordinate plane and sketch that curve. I already did that. That's back in 1, 2, 3, and that thing goes down to infinity and goes up to infinity. I would even draw a dotted line, which kind of says there's a vertical asymptote right there. Draw a vertical dotted line through the point of x values that is not a part of the domain. Oh, I did that already. There we go. That's how you do that one.